you carry O-positive blood, you are carrying far more than a letter and a plus sign. On a medical chart, it looks almost ordinary, a small administrative detail designed to keep a transfusion safe. But beneath those two symbols lies a molecular record older than any written language, any border, or any family name. Your red blood cells carry tiny surface structures that have been tested again and again by parasites, viruses, bacteria, migration, chance, and survival. They are not a perfect shield. They are more like an ancient passport, stamped by every biological battle your ancestors managed to survive. And here is the mystery. The very same blood type can appear protective in one disease and dangerous in another. A hidden advantage, a hidden cost. At first, that sounds impossible, but evolution is not an engineer building a flawless machine. It is an accountant balancing one risk against another. And the first entry in that balance sheet was written inside a red blood cell infected by one of humanity's oldest enemies, malaria. For thousands of years, malaria has hunted humanity without armies, weapons, or borders. The parasite enters the bloodstream, slips inside red blood cells, and changes the way those cells behave. In severe malaria, infected cells can attach to the walls of tiny blood vessels and pull healthy cells around them into clusters. Imagine a traffic jam forming inside vessels so narrow that blood cells must pass through almost one at a time. As the jam grows, oxygen struggles to reach vital tissue, but type O blood changes that scene. The clusters, called rosettes, tend to form less strongly. The infected cells do not gather surrounding cells as efficiently, and the traffic jam is less likely to become as severe. This does not make anyone immune. The parasite can still enter. The fever can still come. But across large populations, type O has been associated with a lower risk of the most dangerous forms of malaria. One tiny difference on the surface of a cell. A difference almost invisible under ordinary life. Yet in a village repeatedly struck by malaria, it could mean the difference between a child surviving the fever or disappearing from the family line. No one chose that advantage. The people who carried it were simply a little more likely to wake up, recover, grow older, and pass it forward. Generation after generation, the smallest cellular difference could leave a mark on entire populations. It makes type O look almost like a biological superpower. Almost. Because malaria was only the first clue. Then scientists followed the trail into a completely different part of the body, the digestive tract. There, norovirus behaves less like an invading army and more like a burglar searching for the correct lock. To infect a cell, different strains must recognize and attach to specific carbohydrate structures on its surface. Those structures are connected to the ABO blood group system, but there is another switch hidden behind the door. Secretor status. Some people display blood group-related markers in saliva and along the lining of the gut. Others do not. That small genetic switch can change which viral key fits which cellular lock. So the story is not as simple as saying type O is protected. Some norovirus strains may infect people with type O very efficiently. Others follow different patterns. Secretor status can matter as much as blood type itself. But the deeper image remains. Your blood type is not confined to a transfusion bag. Its molecular language can appear on surfaces throughout the body, quietly shaping which pathogens find a doorway and which meet a locked entrance. And every doorway that stays closed to one threat may remain open to another. Nature never hands out a gift without sending a bill. Every adaptation is a negotiation. Every advantage sits on one side of a scale, while another risk waits on the opposite side. Turn the scale, and the same blood type that softened one biological attack can intensify the next. The clearest reversal appears with cholera. This time, type O is no shield. People with type O are not necessarily more likely to catch the infection. But once cholera takes hold, the disease can become more severe. Inside the intestine, cholera toxin hijacks the systems that control salt and water. It is as though millions of microscopic floodgates are forced open at once. Water rushes out of the body, and dehydration can become life-threatening with terrifying speed. For reasons linked to the way the toxin interacts with intestinal cells, that response can be stronger in people with type O. The same blood group that reduced the cellular traffic jam of severe malaria now stands on the dangerous side of a different equation. Then there is Helicobacter pylori, a corkscrew-shaped bacterium able to twist through the stomach's protective mucus and settle close to the lining, sometimes remaining there for years. Type O has been associated with a higher risk of certain ulcer-related outcomes. Again, blood type is not destiny. It is not a diagnosis waiting to happen. But when researchers zoom out from one person to thousands, the pattern becomes visible, and the trade-off continues inside the blood itself. People with type O tend to have lower average levels of von Willebrand factor and factor VIII, two proteins involved in clotting. Picture a repair net forming over a damaged blood vessel. With fewer clotting proteins available, that net may build a little less readily. This is associated with a lower risk of some dangerous blood clots. But the opposite side of the same balance is a slightly greater tendency toward bleeding in some situations. Less risk of unwanted blockage, less forceful repair when bleeding begins, protection from severe malaria, greater vulnerability to severe cholera. What looked like a contradiction is now something much more elegant, a pattern of biological trade-offs. All this time, the answer was hiding in plain sight, not in the diseases themselves, on the surface of your cells. The ABO system is built from molecular markers produced by genes. Type A adds one structure, type B adds another. Type AB carries both. Typical type O blood keeps the underlying H structure, but does not add the A or B version. That biochemical difference is tiny, yet it changes how antibodies recognize blood and why transfusion matching can mean the difference between rescue and catastrophe. But evolution never saw a hospital chart. It saw every interaction those markers influenced. A parasite trying to turn blood vessels into a traffic jam. A virus testing cellular locks. A toxin forcing open microscopic floodgates. A clotting net forming too quickly or too slowly. Across thousands of generations, those pressures mixed with migration, isolation, chance, and founder effects. Small groups crossed mountains, coastlines, frozen landscapes, and oceans. They carried their blood group genes with them, not as a chosen identity, but as invisible passengers inside every cell. Some variants became common in one population and rarer in another. Not because one blood type was universally superior, because different environments rewarded different compromises. Your blood type is not a precise ancestry map. It cannot name one country, tribe, or migration route for your family. But it is a surviving fragment of a biological system that traveled through human history long before medicine learned how to read it. So if you have O-positive blood, do not see it as lucky. And do not see it as unlucky. It does not make you immune. It does not predict your future, and it does not define who you are. But it reveals something extraordinary about the body you inherited. A microscopic feature on a cell can echo through fevers, epidemics, migrations, and generations. Your body is not a perfect machine designed from scratch. It is more like the oldest history book ever written, edited by survival and carried forward one generation at a time. Some pages record protection, others record vulnerability. Together, they tell the story of compromises that worked well enough for your ancestors to survive. That may be the real hidden superpower of O-positive blood, not invincibility, not destiny, but the fact that something as ordinary as a letter and a plus sign can open a window into an ancient biological journey. The next time you see O-positive on a medical chart, you may no longer see a simple label. You may see malaria inside a red blood cell, a virus testing a cellular lock, a microscopic scale balancing clotting against bleeding, and behind it all, countless generations quietly passing the same molecular story forward. a story your cells have been carrying all along.